Hi there guys, welcome to this second video on recurrence relationships. Now, so I've mentioned this in previous videos, but they may ask you whether a sequence is increasing or not, or decreasing, or something we call periodic. So if I use the language the next term is greater than the previous term and less than, it's going to make a lot more sense. So a sequence is increasing if the next term is always greater than the previous term. A sequence is decreasing if the next term is always less than the one before it, the previous term. And a sequence is periodic if the terms repeat in a cycle. So it says it's easier to explain it when you see it, but so the next term or a term along the, it's not the next term because it's plus k, so if it was the next term it would be plus 1. So a term in the future is equal to a term that you started with. Okay, and that value of k would be what we call the order of the sequence, and you'll get it when you see this one. So you can see the next term is always more than the previous term, so it's increasing. The next term always gets smaller than the previous, it's decreasing. And here you've got minus 2, 1, minus 2, 1. You can see there is repetition, and we would say this has an order of 2. Sorry, a period of 2. Yeah, I think you can say order as well, I'll check that. Now, 1 minus 2, so that's going down, and now it's going up, so it's not increasing or decreasing. But it could still be a periodic sequence. But you can see that, you know, if it kept going, there might be an order, like a huge order or huge period. But there isn't, so it's just neither. It's not very interesting. So maybe we'll just look at a couple of these. Let's just scrap that one. That looks too easy. So if we look at this one, so we know the first one is a half. So let's just write the whole thing out. So the next term is equal to the previous term squared. Oh, that's it. So when n is 1, we get the second term is u1 squared. u1 is a half squared, so that is a quarter. When n is 2, we're going to get the third term, and that's going to be the second term squared. That is a quarter squared. That is a 16th. So we can see it's going from a half to a quarter to a 16th. It's always getting smaller, every one. So this is a decreasing sequence. Okay. Let's just tidy this up a bit so it gives some room. C, we've got a bit of trig in here. So you can see it's not a typical recurrence formula because we haven't got like the next term. So let's just see how this goes. Okay, and that's important because it's in degrees. Actually, that doesn't matter. If it was in radians, you may not have done that yet. It doesn't matter. Right, so when n is 1, so we get u1 equals sine of 90 times 1, so that is just 90. And you should know from your sine knowledge, sine 90 is 1. When n is 2, we're going to get the second term, and that is going to be sine 90 times 2, sine 180. Here we are, we're at 0. When n is 3, we're going to get the third term is sine 90 times 3 is 270. So we're here, we're at minus 1. And when n is 4, we're going to get the fourth term is sine 360, and we get to 0 again. So it's going from 1 to 0 to minus 1 to 0. Using our knowledge of this, the next one, so u5 is going to be 1, so it's going to go 1, 0, minus 1, 0, 1, then back down to 0, minus 1, 0. So you can see there's a period of 4. Okay, so this is periodic with a period of 4. There you go, I was right. You can say its order is 4. That's what I normally say. It just confused me a bit on the last slide. Okay, so it's an order of 4. So this isn't really anything to do with that, but it is a recurrence formula, and it actually looked a bit more interesting, so I thought I'd chuck this on this video. And then I've got a right stinker coming up there, so get ready for that one. So if you fancy it, pause the video, see what you can do, and then watch it, and hopefully get that warm fuzzy feeling for getting it right. Right, so here is our recurrence formula. Looks okay. K is positive, it's always worth noting, because if you get a negative value and a positive and you write both, you've just lost yourself a mark. We've got this first value of being 2. Right, so let's just go in our usual fashion. When n is 1, we're going to get the second term, and it'd be k lots of u1 plus 3. Okay, so we've got k lots of 2 plus 3. That's 2k plus 3. So that's that one done. When n is 2, we're going to get the third term is k lots of the second term plus 3. That's k lots of 2k plus 3. And then we're going to have another 3 on the end, which gives me 2k squared plus 3k plus 3. Nice quadratic. Alright, that was pretty easy. Now, given that the third term is twice the second term, okay, so this seems pretty straightforward to me. So the third term is twice this, so I'm just going to times this by 2. So we've got 4k plus 6. I've got a quadratic, I'm asked to solve everything on one side. Oh, a bit hasty with that plus there, so minus a k and then minus a 3. So let's factorise. So it's prime, so let's just go straight for it. And this is prime as well, so it's either going to be 1 and 3 here or 3 and 1. If I put the 3 there, I'm going to get 6, so that's not it. So 2, take away 1. So from here, we get k to be 3 over 2, and we get k to be minus 1. But what did it say earlier? It must be positive. So let's not write this one. Okay, so here we go. Time for the big guns. We have a sequence. There's very little numbers, so it's going to really test your algebra skills. So u1 and u2 is b. We've got this recurrence formula. We have to show that the sequence is periodic. So it's kind of nice. We've got to keep going until it repeats. If it just gets uglier and uglier, often you've done something wrong. So pause it, have a go. Okay. Let's just go into our usual structure. So when n is 1, we're going to get the third term is 1 plus the second term over the first term. So that's going to be 1 plus b over a. So far so good. When n is 2, okay, I'll just highlight this a bit clearer. When n is 2, we get the fourth term. That's going to be 1 plus the third term divided by the second term. Okay, so 1 plus the third term, well that's 1 plus b over a. And all of that's going to be divided by the second term, which is b. Right, so let's tidy this up. 2 fractions need to be added together. So if I do that, I'm going to get a plus 1 plus b all over a. And that is being divided by b, so I'm going to times it by 1 over b, because I don't want a fraction in a fraction, that's just minging. So I'm going to put a plus b plus 1, because it's just a bit tidier, all over ab. Now can I do anything with that? No, it doesn't look like it. We can't factorise, can't divide by a common factor, so let's just leave it like that. When n is 3, so we've got, I want to keep going really until I get back to a's and b's, and then I can see what the order is. So when n is 3, I get the fifth term, 1 plus the fourth term all over the third term. Okay, so it's getting ugly now. So 1 plus a plus b plus 1 all over ab over the third term, which was this one over here. So 1 plus b all over a. Yeah. Right. So let's deal with this top. So that's going to be ab plus a plus b plus 1 all over ab. Now what I'm going to do is just make all of this a bit smaller. There you go, that'll do. And I'm going to times that by a over 1 plus b, because a keep change flip, I'm dividing by that. So keep change and then flip this over. Right, so let's get cancelling. So I can cancel those off. Now I'm going to rewrite it because I want to show you something here that I've spotted. So ab plus a plus b plus 1. I should put a 1 there. That's a bit naughty of me there. So that's fine. And then what I have here is b lots of b plus 1. And I'd really like to be able to cancel something. So can you see this bit here? If I factorise for a, what I actually get is a b plus 1. And then I have another b plus 1. So I have two terms. So if I can divide the entire top and the entire bottom by something, then that's great. That's going to simplify it. So if I divide this term by b plus 1, it's a 1. If I divide this term by b plus 1, anything divided by itself is 1, and the same here. So I actually end up with a plus 1 over b. Right, it's going to make me go further, isn't it? Right, so, wow. One more. We're nearly there. I hope it's one more, unless I've gone horribly wrong. So when n is 4, we've got the sixth term is 1 plus the fifth term all over the fourth term, which was a plus b. Oh, naughty. I'm not that stage yet. Okay, so it's 1 plus the fifth term, which was this one. So a plus 1 over b all over the fourth term. That was the uglier one. So that's a plus b plus 1 all over ab. Okay, so let's just squeeze it in over here. So that's b plus a plus 1 all over b being times by ab over a plus b plus 1. Okay, this is nice. I think this is going to work. So we can cross cancel there. That's a 1. Cross cancel here. That's giving me 1s. 1 times a is a over 1. Hey, we got an a. Right. So what do we have? We have a, b, 1 plus b over a plus b plus 1 over ab, a plus 1 over b, and then a. Right, I'm going to assume, I could work it out, but I can't be bothered. The next one is going to be b. So it's got a 1, 2, 3, 4, 5. Periodic, order 5. Bosh, done. Glad that's over with.